Hey, this is a Sprint 7 video report from Murray Campbell. This week was all about getting the collision test system to actually check for intersections between bounding spheres. So that built on top of last week's work, which was setting up the systems and commands to handle that. And this week's work was in passing through basically a bunch of making calculations and passing information through to the collision test commands. Alongside that, we did a visualizer, which basically, yeah, you know how the visualizer works. It'll display the bounding sphere on the screen, but it's not an actual bounding sphere. It is just a representation of that space. So I'm going to go ahead and play it just to show you that it works. Let me actually... So I implemented the God camera. Apart from... I took the flying camera from the like flying camera project in the getting started thing. And I implemented that, but I'm used to having a translate up and down, just like straight up and down button. So I added that too, and that helps. That helps me make more precise movements when I'm doing the God camera. It's just a preferential thing. Okay, let's see what I did this week. Oh, another thing was last week I changed my project hierarchy, and then this week I did it again. Collision is back in a folder called Collision. I just wanted to keep Collision on its own. Game object has all of its ubbles and other things and stuff like that. This is just what makes the most sense for me to work with, so that's how that works. Okay, so in the game, we can move around, we can shoot. The visualizer, like bounding sphere, updates to represent the model's bounding sphere. And you can see that it's relative to the model's center and radius point. So you see that I'm just turning right now, and the bounding sphere, the center is moving like that. So that's how you know. Also, I have the collision system. So when you collide with these cottages, you'll it can do whatever it gives the collision callback. So there's that, and that works, and it's really cool. It's really great. So yeah, that's pretty much all that needs to be shown. Let's see. So we made changes in the collision test pair commands and the collision test self commands. So in collision test pair, we iterate through these collections, and then we assign a bool called test result, and we make that. I use that to call the collidable static method collision test pair with the first iterator and the second iterator, and when it does that, that's in collidable. So it's a static method. In collision test pair, it tells the bounding sphere, calls the bounding sphere intersect method, and takes in the second collidable as a parameter. So that goes through to the bounding sphere class, which has the intersect function, and that takes in the bounding sphere, and that returns the intersection in the math class, using this and the other bounding sphere. So we go all the way to mathtech.cpp, and we have this intersection function, which basically is the center 1 minus center 2 squared. Like if that is less than radius 1 plus radius 2 squared. So plus, and this one's minus. So there's that. That tests for intersection and doesn't use any square roots, so that's good. So we have that in the collision test pair command, and in collision test self command, we do the same thing, except we iterate through the same collection twice, and if these two iterators are not the same, then that's how we know that it's not we're not looking at the same, the same thing. And we can test for collision self. And it uses the collision test pair and does the same sort of thing. So there's that, and that works, and it's good. Oh, and in regards to the collision test self command, I don't know if this is like the best way to do it. It feels kind of bad, but this is what made sense to me at the time, so I put it in. Let's see what else changed. I guess I can show the visualizer class. Basically, it's the function to render the bounding sphere. We do some things like we set the scale equal to the radius times just a unit vector. I think that's not the correct term. It's just a vector with 1, 1, 1. I don't set the W because that's default to 1. Yeah, so this is, I guess I'm talking now about how the data is computed. So if we go into Frigate, once we set the collider model, and then in update call this update collision data. Update collision data tells the bounding sphere to compute the data, and so we go to the bounding sphere, and in there we calculate the center and the radius of the bounding sphere for the model. The bounding sphere for the model, and that is the center. The center is the center of the model times the movement matrix, basically like the positional the transform, rotation, scale matrix, that sort of thing. The world matrix, that's the best term. And then I create a radius as a vector. So we discussed this in class, but basically I just did the radius and then 0, 0, 0. I had to do 0 here because the vect class defaults W to 1. So that had to be made explicit, and that might have caused issues otherwise. I'm not sure. And then we multiply that by the world matrix as well. And then we take that vector and we get the magnitude of it, and that is our new radius, and that is how that works. So yeah, that's pretty much how that system works. Apart from that, I don't think I have anything else to show. So that'll be it for this week. Thanks for watching.